It's cloudy out here. I hope the weather at your place is much better wherever you are watching from. For those of you who do not know me, I'm Dr. Nandi. I frequently go live on my YouTube channel and I discuss different math problems, different math topics. Also in my channel, I have uploaded a number of YouTube videos showing how to work out problems, all kinds of math problems, algebra, statistics, calculus. So if you get a chance, please take a look at my channel. If you like my videos, please give me a thumbs up and please subscribe to my channel by hitting the red subscribe button. So without further ado, let's get started today. Today we are going to talk about margin of error in confidence interval determination. So we are talking about confidence interval determination, confidence interval for the population mean, and what is the margin of error, and how to finally get a sample size, minimum sample size necessary to maintain a particular margin of error. So let's get started. So let's start with the standard normal curve. Standard normal curve. Okay, so standard normal curve is the bell-shaped, is the probability distribution or probability distribution of the standard normal variable, of the standard normal variable, which is given by the letter Z as in zebra. Okay, so the probability distribution of standard normal variable Z, it is a bell-shaped curve, bell-shaped or normal curve with mean equal to 0, mean equal to 0, and sigma, this is the standard deviation, equal to 1. Equal to 1. So this is the bell-shaped curve. So at the center we have Z equal to 0 right over here. So its mean is equal to 0 and sigma, the standard deviation, is equal to 1. Now around the mean, let's think of an area which is given by the notation 1 minus alpha. 1 minus alpha is the level of confidence that we will select. So area in the center is 1 minus alpha. Area in the center around the mean is 1 minus alpha. So area in the two tails, since the total area in the under the curve, area in the two tails is total area minus the area in center, area in the center. So total area is 1 minus area in the center is 1 minus alpha. When you distribute the negative sign, you get 1 minus 1, 2 minuses make this plus. So area in the two tails is alpha. That is the area in two tails. So because The standard normal curve is symmetric. The standard normal curve is symmetric. What does symmetric means? Symmetric means left half is equal to the right half. Right half. Area in each tail is the two ends. Area in each tail is total area in the tails. Total area in the tails divided by 2. We already established that the total area in two tails is alpha. So area in each tail is half of that. So area here is alpha by 2. Area here is alpha by 2. Okay. Now this particular z values, one on the left, one on the right, they are identical except the one on the left has a negative sign, the one on the right is positive because it's on the right of 0. So this particular value of z, which is a boundary between the left tail and the central region, is called minus z alpha by 2 because the area in the left tail is alpha by 2. This is also sometimes called a critical value. Similarly, this value of z alpha by 2, which separates the right tail from the central area, as I told you, because of symmetry, it's the same value with a positive sign, which we do not indicate. Okay, z alpha by 2. Okay. So previously we have established that the confidence interval for the population mean interval for the population mean with 1 minus alpha level of confidence. Remember, that's the area in the center around the mean. Is given as x bar plus minus z alpha by 2 multiplied by sigma divided by square root of n. Here, this thing x bar is the sample mean. Z alpha by 2 is the critical value of z, which separates the left and the right tail from the central regions, confident region. Critical value of z. Sigma is the population standard deviation. And n is the sample size. Okay. Now the confidence interval is written as given as x bar sample mean plus minus. Why do we do plus minus? Because when we do minus we get the lower boundary, when we do the plus we get the upper boundary of the confidence interval. So what is m? M is the margin of error. And is equal to z alpha by 2 multiplied by sigma divided by square root of n. Okay. So we can write m equal to z alpha by 2 multiplied by sigma divided by square root of n. and we can multiply both sides by square root of n. Cancel this and square root of n out. So we have square root of n multiplied by m is equal to z alpha by 2 times sigma. Now divide by margin of error m on both sides. We get square root of n is equal to z alpha by 2 times sigma by margin of error. Now squaring both sides we get what do we get? Square root of n square is equal to z alpha by, this is square root of n square is equal to z alpha by 2 times sigma divided by margin of error square. Now square root of n square is nothing but n, because it's square root of n times square root of n is equal to z alpha by 2 times sigma divided by margin of error square. Or in other words, square root of n square is equal to z alpha by 2 times sigma divided by margin of error. Sigma, not alpha. Z alpha by 2 times sigma. Or if you remove the square root, it becomes n is equal to z alpha by 2 times sigma divided by margin of error square. Alpha by 2. Now let's do a sample problem. So this is the minimum sample size n. Minimum sample size is given by this formula. This formula. Let 1 minus alpha is equal to confidence level is 0.95, or in other words, alpha is equal to 1 minus 0.05, 0.95 is 0.05. Okay, alpha by 2 in that case is 0.05 divided by 2 is 0.025. So if 1 minus alpha is confidence level is 0.95, then alpha by 2 is 0.025. Okay, so this area is 0.025 and this area is also 0.025. The center is 0.95. Okay, now we can go to our calculator. If we have a TI-84 calculator, we can go to our calculator and find out what is the value of this negative z alpha by 2. Why? Because we know the area in the left tail as this area in the left tail is 0.025. So we go to our calculator, put it on, then we do second button and verse. Verse is in the third row, second verse, and then we are going to use number 3 in norm, not normal CDF. Now this area is always the area in the left tail is 0.025. Mean is 0, standard deviation is 1 because it's a standard normal probability distribution. Paste, enter and enter. And we find this z alpha by 2 is equal to minus z alpha by 2 is minus 1.96 Thus, positive z alpha by 2 is just the same value without the negative sign. So this is when alpha is 0.05, okay, and alpha by 2 is 0.025. Okay, alpha is also known as level of significance. Okay, so we got our z alpha by 2, and negative z alpha by 2 is negative 1.96, positive z alpha by 2 is 1.96. Suppose sigma is equal to 50 and margin of error is equal to 5. Okay, then and 1 minus alpha by 2 is 0.025 and z alpha by 2 is 1.96. Then the minimum sample size n will be equal to z alpha by 2 multiplied by sigma divided by margin of error square. Now we know z alpha by 2 is 1.96 for alpha 0.05, alpha by 2 area in each tail is 0.025. So 1.96 multiplied by sigma, which is 50, and the margin of error is 5 square. So how do you do this calculation in TI 84? Okay, we will just use what the formula is. We put a left parenthesis, inside the left parenthesis 1.96 times sigma multiplied by sigma is 50, standard deviation is 50, divided 50, not 80. So it's 50 divided by margin of error is 5, and we put the right parenthesis. So 1.96 is the critical value of z for level of confidence 0.95, area in each tail is 0.025. So using in norm 3 or second verse 3 or in norm, area in each tail 0.025, you will find the critical value of z as 1.96, that is z alpha by 2. Multiplied by the standard deviation is 50, divided by margin of error 5, and then you got to square it. Do not forget to square it by pressing the x square button and hit enter. And you get the minimum sample size. The answer came out in the calculator is 384.16. We do not round it down, we move it up. N is equal to 385. So minimum sample size necessary to maintain a 5 as the margin of error, and when standard deviation is 50 and 95% confidence, this is your minimum sample size necessary. Minimum sample size. Okay. Let me work through the steps again. We know the confidence interval is given by this formula, confidence interval for the population mean. We do not know the population mean, so we are trying to establish a lower boundary and an upper boundary within which most probably the confidence in the population mean will fall. That formula is x bar plus minus z alpha by 2 times sigma divided by square root of n. What is x bar? Sample mean. What is z alpha by 2 is a critical value of z. Area in the center is 1 minus alpha. Alpha by 2 area in each tail. Okay. So knowing that alpha by 2 is area in each tail, and if the confidence level is 0.95, then alpha by 2 will be 0.025. So we go to our calculator, TI-84, second verse 3 in norm. Area in the left tail is 0.025, mean is 0, standard deviation is 1, best and best, and we get the critical value z alpha by 2 is 1.96. Okay, so, and to us the standard deviation is given as 50, This is an example problem we are working on to find the minimum sample size. Sigma is given as 50, that is the standard deviation. Margin of error we have to maintain is 5. So n is given by this formula. How do I crank out these calculation? I put a left parenthesis. Then in the numerator I have 1.96 times 50 is the standard deviation, divided by 5 is the margin of error, and I square it by pressing the x square button. Although I get 384.16 as the answer, we do not round it up. We always round it up. Why do we round it up? Then we will definitely maintain the required margin of error, which is 5. There will be no problem with that. So we always round it up. We do not round it down. If we round it down, then we will not be able to maintain the required margin of error. So the minimum sample size is n equal to 284. This was just 385. So minimum sample size is 385. This was just an example problem I worked out using the minimum sample size formula, which is n equal to z alpha by 2 times sigma divided by margin of error whole thing squared. Sometimes people make mistake not to square. If you don't square, you'll get a wrong answer. Again, point to note, after squaring I get the answer as 384.16. I do not round it down. I round it up. So n, minimum sample size in this case, is 385. Okay. So, I'll stop here today. In case you have any doubt, any question, shoot me. I will get back to you as soon as possible. Shoot me a question. And if you like this video, please give me thumbs up. That really means a lot to me. I really appreciate that. If you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button. And please do not forget to watch me tomorrow. Okay? Let me know where you are watching my video from. I'm always interested to know where people are watching me from. So please let me know whether it's night or daytime in your place and where you are watching from. And if you like this video, share with your friends, and please subscribe to my channel by hitting the red subscribe button, and also click on the notify bell button. So I hope to see you tomorrow. I thank you very much for taking the time to watch through my video, and I will see you next time. And please do not forget to watch me tomorrow again when I will upload a new video. Thanks for watching and have a great rest of your day. Thanks. Take care. See you.